In this video, I'm going to demonstrate how to use query curves for post-processing creation of graphs, and I'm going to show some of the nuances with respect to query curves behaviors. So I have a model. It's just a flat plate. It's been solved for normal modes. So I'm going to go ahead and display my first mode shape, and then I'm going to want to generate some graphs. So for example, I wanted to graph the displacement variation from one plate to its opposite corner. And so maybe I will turn off the deformation, and then I'm going to go into the create graph command. I'm going to create a graph along the path of the query curve, and in this UI I'm going to create a query curve. And so go in here and say create a new query curve, and I'm going to use the method of coordinates. So when I use coordinates, I'm basically picking points that are going to define a line or line segments. And I can also insert points along segment. In this case, I'm just going to start off with no points inserted per segment, and then we'll get into what a segment is later. So first, I'm going to just pick my first location for the start of my query curve, and then pick another point. And so that defines a straight line. 2 points defines a line. So I'm going to say OK. And now you can already see that I've got like 11 points highlighted, my 2 endpoints plus some interior points. And those interior points are intersection locations. So I have a curve defined by 2 points, and then I have the usage of the curve. If I say use vertices, I'm only going to generate a graph with 2 points. And if I say use intersection locations, it's going to find element edge locations that intersect that straight line. I can also say snap to closest node or use as is. In this case, the curve is crossing right through nodes, so the closest node is going to be one that it's passing right through. And then I'm going to go ahead and create a graph and place that here, and you can kind of see that this graph is segmented by a set of polylines. So if I look at that data from this curve, you see I've got 11 points defining that curve. Okay, so now I'm going to do this again, but this time I'm going to create a new query curve, and this query curve is going to use the same coordinates method, use the same points, but I'm going to insert 50 points along the query curve. So along segments of the query curve. So I pick my first point again, and then my second. Then now I'm going to insert 50 points along the segment. So now I've got 11 segments, right? Or 10 or 11 segments, and then each segment is going to have 50 points inserted between it. So I'm going to have a much smoother curve and a much more dense set of points. I can also, instead of using intersection locations, I can project to element faces, and it's going to project nodes or element edges. I'm not sure how it makes a projection, source, but normal to the element face is the Z global direction, so I'm going to use that. And it finds the same set of points, and each of these segments again is going to be subdivided by 50 points. Then I'm going to create that graph in the same window below, and you see immediately, that this second curve is more refined. It's less of a polyline and more of a curve. And then I view that data. Of course, it's more refined. It has more data points because there's 50 points per segment now. Maybe I can also do that in an example where my points or my curve doesn't pass through nodes on my model. Create a third graph. Create a new query curve using the same coordinates method. And in this case, I'm going to have 0 insert points. I'll go ahead and pick that same first point location, and then another one that's off of that main diagonal. So right there. And to use as the curve usage, I'm going to say use intersection locations. So now it's highlighting the element edge intersection locations. And I should have, it looks like 17 free points are selected. So I'll say OK to this and create the graph, this bottom viewport. So I get a new graph, and you can kind of see the segmentation. So I'm going to probe single X, and we can see the segmentation and the distribution of the points, close, or it's in an uneven fashion. They're not evenly spaced, like we had in the beginning. Okay, so then maybe I'll do that one more time. Hopefully I'll be able to pick the same points. So I need to pick that point there. So it's the third one in from the end, and I'll create a new curve using coordinates and node here along with node there. And I'm going to say 50 segments, 50 points in my segment. And then I'm going to go ahead and create this, and I'm going to overlay in there. And then I have, again, the same situation where my second curve is much more refined than my first, and it is because I have many more sampling points for my curve. Now in this next step, I'm going to create another graph using those same set of curves, but I'm going to use a different approach towards details of the query curve. So again, going back into the create graph, displacement along path, and I think I can even just use the same query curve, but instead of saying use intersection locations, or I can still say use intersection locations or project element face, but I'm going to snap to the closest node. So there, I'm seeing a filtered down view of nodes that I can snap to, and I do have a parabolic mesh here, so you can see I'm snapping to some mid nodes, to some vertex nodes. If I go back and say use as is, we can also see that some of these locations are going to resolve to the same node. So where I have the same node being found, I think those values are going to be cast aside. So for example, there was two nodes or two intersection locations but found one node, so they were eliminated. So then when I create a graph from this, it's going to be very coarse, but I'll go ahead and do that, and then I'll overlay that onto this view, and we see, our resulting curve as being much more coarse because of the lack of data points in this model. So what we showed here was the creation of a graph along a path, defined with a query curve, and the different settings of those query curves of using just intersection points, using intersection points and then additional sampling points between the segments between those intersections. And then we also created a graph in which we were just using nodal data that the query curve found.